Record again. Right, let's record again now. So, ready guys, please? Yeah? So here's your topology. Okay, let's go to do a bit to and fro with this. So first of all, how many networks? Talk to you about this all. Right, there are 5 networks on this topology. 1, 2, 3, 4, 5. Networks have a prefix on them. Okay, R1 has 2 directly connected networks. R3 has 2 directly connected networks. R2 has 3 directly connected networks to it. Because of that, if R1's only got 2 directly connected networks to it, it doesn't know about how to connect to this one, this one, sorry, this one, and this one. All it knows is it's got to find the next hop place, which can then work that out for it and beyond. That's the logic of it, yeah? So when we're configuring routes, I go through the answers here, yeah? 2, 3, and 2, as I said, and inversely, 3 static routes, 2 static routes, and 3 static routes, opposite to this. You okay with that?
Yeah.
So far? Then you're testing the connectivity, the pinging is not going to work. No routes to these networks on R1. Yeah, no routes there. Configuring recursive static routes in R1, so it's definition there about, I was mentioning about lookups and looking at the interface. Here's your configuration, there's 3 lines there. You're going to stick this into a notepad, all right? Check you've all done this right, like this, and let's bring this up to right underneath this diagram here. And how enough you derive this. So the first one we're looking at here is IP routing. The syntax, give me the syntax, folks. What's the first command always in the IP route function? What's the first command here always relating to? What is this first address? When you're giving this on your
That's the network address we meant to be going to.
Okay, so 0.0, right?
Yeah.
Okay. And it's 31.0.0. This is, we're doing configuration for R1 right now. Yeah, we want to get to this network. Sorry, 30, God, where's it gone? 31.0.0, which is up here. God, I need to get from here to here, right? Yeah. Other one I've got to do is 1.96. Okay, here, because I don't know about it, and 128. So this one, and this one, the 3 static routes that are not directly connected. Therefore, that is the first part of the command here. Does that make sense? Folks, the network address, yeah? Are we cool with that? Any questions on that one? I'm assuming yes, folks. No one's saying no yet. All right. Now, given that's the case, yeah, your prefix here that goes along with this, your prefixes is /24, right? And then your /30, and then your /26 will give you your subnet mask. Are you happy with that?
Yep.
Yeah, that's all just based on the prefix. And finally, what's the last section of this? That last, what's that about? No, it's always the same, yeah? So what is this, folks? Next hop. Thank you. The next hop is what this is. So we've got to get the hop right. So this is 31.1.193. Where is that?
Between R2 and R3.
You think it's there?
Yes, between R2.
Oh,
No, it's next to the interface on R2 from R1.
We need to get this area here, right?
Yeah, it's 0, 0, 0.
Yes, yes, between R1 and R2.
So this is the route, the hop route, okay? Now your table here tells you the R2, okay, the S00 interface, okay, the serial interface in. When you turned it on, Paul, just to sort of verify this, when you switch on your ports, what does that give you there when you hover over that one and this one?
S0, 0, 0.
And this one?
Yeah.
0, 0, 1.
S0, 0, 0.
It's 0, 0.
00, right?
Yeah.
So the address for this particular route, okay? Okay, the IP address on that one is 1.193. Okay, to that point in. So there's your next hop address there. Now, similarly, the other routers will be configured the same way. So, once you first do this, what it will say is, although R1 can now get to R2 and R3 LANs, R2 and R3 haven't got routes back. Okay, so it's not successful, this thing. Okay, so now the next configuration is your directly attached static routes on R2. Configure directly. So how does it differ? The difference is it relies on its exit interface for packets to get to its destination. Okay, the recursive actually uses the IP address of the router, but directly attached ones just use the exit interface only to get there to its destination. It needs to know what is the way out, is what it needs to know. Whereas if it's recursive static, it's using the IP address of the router. That's the difference. So now it asks you to configure the static route from R2 to every network not directly connected. So R2, let's get his 2 lines. Okay, here's the 2 lines here. So it's just saying here, from R2 to every network not connected directly. So here's R2 here. What's not connected directly to R2 from here? On the diagram, folks. Yeah, are you cool with that? It's direct, that's direct, that's direct. What's not direct? There's 2, isn't there? Yep.
PC1,
This lot
Yeah.
and that lot.
S1 and S2.
Great. So now we've got to add them in, right? So this is a direct connection, and this is not directly connected. So what we're doing here is now, it's saying you should use the actual serial connection, the interface to do this. Okay, this type of connection. So the IP route to get to 1.0 with that subnet mask is through the serial 00 interface. And the 01 interface is this way to get to that address via that subnet mask. Okay, that's how R2 is configured. So that configuration is just how do you verify it? There's 2 verification routes there, that one and that one. Okay. 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 Is that okay, folks? That configuration. And notice the syntax is a bit different. This is the router address because it is a recursive static route. Okay. Not, that's why it's using this router to get there. This is directly attached, so it's a serial out on that one. That's step 2. Finally, okay, it's a document the commands here. A default route in R3 is also required. Okay, it's asking for a default route. So how does it differ? This is the backup route, okay? The gateway of last resort, where you go when nothing else works, okay? That is the configuration command for that. Quad 0, and then the serial out 001. Now R3, S001, here, okay? This is the default exit route out here. That's what's being configured at that point. Here's your serial out. So anything which cannot be handled by this router in, it's going to say go this way towards R2. It doesn't even need to say R2. It's just saying the exit interface is this way for that stuff. Yeah, that's the tunnel for it. Yeah.
Instead of typing the serial interface exit, what if we type the IP address of that serial interface?
It's just to do with the syntax for when you do a default route. That's why. Reading a default route, yeah, that's the syntax you use. Use the interface exit. Yeah, it's just appropriate rules for different things. This is the situation where you've got a default route. Whenever you are asked to do a similar thing in your networking skills assessment or wherever, it mentions the word last resort. Here we have last resort, yeah? as it says here, when no other known route exists for a destination network, then you have to interface, you have to write the syntax as that. Serial 001. Yeah? That's what's behind that one. Okay. It says document the commands for the fully specified routes. So the fully specified ones always contain both the interface and the IP address. So Betty, you're saying that, you know, this is how you do the syntax for this. The fully specified route, if it ever asks you for that, you have exit interface and next hop address. Okay. It says packet tracer doesn't currently support these. Okay. So it's just saying just document how this is done. But if you were going to do it as you asked me, that's how it would look. From R3 to R2, yeah? This is the pathway for it. The fully specified version. And it says do it from R3 to R2 and R1, and it's doing that as well. That's another fully specified route. And finally 2. You will have this maybe in your theory exam. Yeah? It will give a suggestion to do something like that. And you need to remember that the full path looks like this if it asks you for it. It might say something like, which one of these routes is going to fix the problem? A, B, C, or D? And this then to catch you out, it might say fully specified, and you know this is the type of syntax you use for that. Okay. Now verify is testing, so you guys can do it in your own time. You just verify connectivity. You've got your show commands, and that will take you through the rest of the packet tracer activity there. All right. Now I should give some time. First, let's check if you have any questions, folks. I should give you some time now on IP version 6 too. Yeah, you need the IP version 6 stuff also to be delivered. Yeah, any questions there? That's something you guys can carry on now and do comfortably, you think? Everyone get it finished in the lesson anyway, or nearly. How far do you getting that video to help as well, right? Give you some aid. Was that a good video, that one you're watching? Good one. Who's it by? Ramirez.
Yeah.
It's Ramirez, is it? Okay. I might post that and share that anyway. Right.
Yeah, the new guy as well, please explain a bit, Mr. MCAEE.
New guy, new kid on the block.
This is the new guy, yeah. I got proper English research.
This video will be available anyway. This video. I have a PDF file of this. I have a PDF file of this particular solutions. Yeah. If you need them, it's worth me sharing some of those. I'm going to show some other resources today, actually. So when I get to the end of the lesson, I'll show some other stuff I'm going to include. One is a video lecture of the CCNA2 chapter to help support my lecture. Additional, a guy who's just like, will say a bit more about certain things that I might not comment on, so I'll include that. And whoever was watching that with me earlier, it's quite good. Okay, right, let's get back in.
Very, very good. Yeah, it's very, very good. I just
Folks, there's a fair bit of stuff in there. I think it's been good doing more time on the practical today. Just slowing down a bit and just doing it together. It's been quite useful, methodical. So I quite like that. Although we haven't covered as much ground, it's been useful to understand stuff. Right, folks. So here we go. Ready, Stuart? Yeah. There we go. IPv6. So, folks, here we go. We need to know about the IP version 6 commands. If you want more practice, I would say finish the packet tracer off. Yeah. And then the lab is following from that, which is just where you mark up your own stuff using the packet tracer environment. And there'll be some videos for companions to this, 2225. YouTube will have that companion on there also. 39 slide, okay. IP version 6 root. Now, here we go, folks. So again, it's just syntax. How do we make a routing command? IPv6 root. Prefix / which is a net address. Prefix length. IPv6 address, exit interface. Example, coming up soon. You need to enable IP version 6 packets to be forwarded in the first place. That requires you to do this command. IPv6 unicast routing enables the forwarding of those IPv6 packets onward. Okay? There's progress there. Okay? Each router only knows about directly connected networks. So R1 can ping R2. I can't ping R3. Same problem as before. next hop needs to be identified by the IP version 6 address. Somebody, this one, R3.
Yeah,
Not-
because obviously R2 would know R3.
R2 does it, but it's not been, R1's not been configured, right, in the way that it knows R2 is the next hop to get to R3.
Oh, right, yeah.
It just goes, R2 is for these reasons, but not beyond that. It doesn't really get that idea, right? So you configure R1 to know that. Like R1, you can go to this network, by the way, via R3 if you go to R2. Then it doesn't have a clue otherwise, yeah. Yeah? Can be defined. So the route is not known to R1 yet. Yeah? Okay, so so how do we identify the next hop? We have obviously now the IPv6 address, exit interface, or both. 3 route types: next hop static IP version 6 route, directly connected static IP version 6 route, fully specified static IP version 6 route there. Yeah, those are the 3 different things. Okay, there's a 3 routes we want to work out how we configure those. 43. 3 next hop, okay, these are showing here. We now have the configuration of 3 next hop static routes on R1. R1 configuration will get me to a CAD2, a CAD5, and a CAD3 down here. It's all this lot. These are already directly connected, right? But via a CAD4 : 2. You see that? Which is right there. Okay? Same as IP version 4. Similar approach. Okay? Simpler instructions though. Is that all right, everyone? Yeah. So as with IP version 4, must resolve the route to determine the exit interface. So they've got to work out what that is. Okay? And it does match the route up. And it's with the exit interface serial 000 out this pipe here. That's the way out there. Good. Now, the alternative to next hop and giving the router address is to specify the interface always. So the packet's destined for a CAD3, which is down here, forwarded out to serial 000. No other lookups are needed. Okay, that's how you do a directly connected static IP version 6 route. Okay, so here's how it's shown here. Whoops, let's go down here, down here. There you go, there's the definition there. You know, in contrast to previously, we've got the S000 interface being given there, and that's how you do a directly connected static IP version 6 route. 5, how you configure a fully specified static route. So what's that going to contain, folks? I mentioned earlier, what's got to be in a fully specified route? Oops. What are the 2 key things in that one? I mentioned it earlier on for IPv4. What have you got to have in the fully specified? Betty, you know this?
Yeah, including the syntax, writing the serial interface
And
the IP address. Okay.
interface and mask, yes, as well, and
What was the word?
there's a link local address in this as well.
They have the same user interface.
Not only do you give the interface address, you also give the address for where it's going to also. Yeah. So for IP version 6 fully specified interface, which is going to be, you can see here, yeah, this example. There's an error showing here, right? Look at this, it's picking up. The address is going to also. So we're configuring R1 to get to here, right? R2. I tried doing it. I want to get to my CAD2 network. That's where I want to be, right? I'm giving it the address now for that interface. No, it's normally like, you know, we say it's like IP, but it's like we give IP address 0.2, whatever it was on the last example. The IP address here is the link local address on this example. FE80 : 2. That's the address of that interface. I didn't like that. He wants me to give the interface also, which is a serial interface, 000. That's fully specified. Okay? So you give the serial interface and give the actual address, which is often the link local address. Yeah? That's the next hop. Remember that for IP version 6. Verifying routes now, just some commands for you folks. It's simply just IPv6 route static, okay? And show IPv6 route, and then the actual network address you want to look up and go down. That's showing you the way to get to that particular network via the route. And here's show running config. You can even do a section command on that. Let me zoom in on this. Yeah, there's your commands to remember and write. That's for your engineering journal, folks. Righty-ho, on 47. So here are the configuration commands I just showed you. So how you default, here's just the commands, and these slides will show you what they are. Okay, the configuration of the route. Here's the configuration of a static IP version 6 route. So IP version 6 route. Remember how do we do this on the previous one, folks? Remember? Let's go back. How do we do default statics? Remember, the default is the last resort. How are we doing that in IP version 4?
All zeros?
Yeah, quad 0, right? Any address. So the equivalent in IP version 6, okay, all packets not matched in routing table, is like last resort, is ::/0. All right? That's any IP version 6 prefix, doesn't matter what the prefix length is. You cool with that? Yeah. That's that one there. Is that all right, guys? Yeah. Okay. So here's a configuration taking place here. In this example, R1 is a stub router, only got one connection. So
This stub router, we're going to use in OSPF system.
OSPF?
Yeah.
It's used in other routing protocols, yes. In this example, the stub router here, you would have, it is a simple situation, which has one neighbor on it. So given this like this, it's more efficient rather than having those broadcasts and a dynamic protocol going on to do a default static IP version 6 route straight to the disk. So R1 being configured, quad 0, that's all packets, go to a CAD 4, okay, :2 there. That's the way out to anything from that network, stub network. Easy again. It's a bit repetitious on this one, I must say. Okay, so 49 slide, there we go. How you verify it? So it just says, to verify, it's just saying these commands, IP version 6 route static. It's got a ping also. Can I ping a CAD 3:1? Can I get here from here? And it's showing it's possible and how it's done. Packet tracer command. Now, this is a IP version 6 static and default route configuration. I'd like to ask you, I mean, in terms of what I've got to cover in terms of material, I don't need to cover the troubleshooting stuff, I don't think so much, just as you guys are going to be doing that anyway. So I want you to practice for yourselves, have a little problem solving thing yourself that you're going to do on troubleshooting, solving a problem. Yeah, you're going to solve that problem. The routes aren't working, sort that out, okay? That's your job as networkers. In terms of my material to go, I've got to do, this is all troubleshooting as well, actually. This is just troubleshooting stuff, so leave that with you, okay, on troubleshooting. Is that okay? Yeah, I think it's just for you to do as your own work. So for me, oh, not far from it. I've got to do these slides to go. So let me just finish these slides off, and then you'll have a bit of time to look at the IP version 6 config. Yeah, configuring IP version 6. It's, again, as you saw, straightforward. Famous last words. Okay, so that's the one you're going to be doing in a little while. 224, configuring IP version 6 static and default routes. I'll give you the choice, actually. If you don't, that's something you can do quite routinely. You might have much more fun having got the troubleshooting one and just attacking this one as a lab, right? That's quite challenging, you know, just working out the problem. But I will also provide you a solution sheet this time. I'll give you a PDF file, which you can look at, no peeking, but you can look at to help you when you get stuck, yeah? So you have as a backup. Let's finish this off. Right, so having done the IP version 6 configurations, let's now talk about the static routes, the floating static route. Now, this is where I'm going to override my normal dynamic routing protocols or any other routes with my own route, okay? Hence floating. This has to do with backups, okay? Where things are going to, if you've got a backup problem, say you want to get to the internet and the main link fails, you've got a backup route to it also. So you make a floating static route for that reason, and you give it an override, okay, which means having a different admin distance, okay? An admin distance which is greater than the dynamic routing protocol or other static routes. So if the other ones fail, it'll go down in the order, right? That fails, that fails, that fails, that fails, that fails, and it'll go down to a higher value. Say it was 130, for example, and that's my floating static route, and it will go to that one instead. So these are backup routes. These are other well-known ones. By default, the AD of a static route is 1. Normally, it's very low. Okay. The static route AD can be increased above this to make the route less desirable until the preferred route is lost. So I might prefer to go down the other routes. Yeah. If I made AD 130, and that's my backup route, it's less desirable. If something else fails, then I'll come on to that one. Okay. So configuring and doing this, the way you do it, I zoom into this one, look over here. So we're configuring a route to R3 from R1, but a static route this time. IP route quad 0, 172.16.2.2. This is going right there. Okay? Yeah? Now here we go. I'm now changing the admin distance below this one. Quad 0, 10.10.10.2, 5. This value is the admin distance being overridden. Okay? Right? So 10, where is it down here? Yeah, 10.10.10.10.2 is right there. Yeah? And I'm making that admin distance override. Okay? So
Where's the 5? Where's the 5?
What is the 5?
it is an admin overrider.
Oh, okay.
AD.
Oh.
It's just that we've increased the distance.
So
Yeah.
is AD always given to you, or you have to figure it out? Or?
If you're doing a floating static route, you've got to provide it. Yeah. So it becomes less desirable. Desired route 2.2. Less desirable route. If this fails, go this way. Yeah. Backup plan, right, guys? 2 routes. Route number 1, priority route. Backup route this way. AD for this is what? Exactly, 1. Well done, Paul. This is a default route, 1. And this is 5, which means higher than. This is your next preferred route. All right? If that link breaks, some hedgehog bites the cable, then that's the way through. Okay. Right? 54. That's the real issue with networking, but actually it's hedgehogs.
Sorry.
Sorry.
The reason you dot 5, there is no dot 5 at the alternative route.
It's not a dot, it's actually an admin distance I'm giving. 5 is a number.
It's
not a network number.
Okay, that's the 5th one. Is, okay, there is no dot in there. Is
No.
there?
No dot.
Fifth is AD.
What might be happening though is because you do so much networking now, you start seeing dots in places. It happens after some Cisco. Usually after Cisco 2, you start seeing dots. Happened to Stuart earlier.
This board is not high quality.
I won't predict. Stuart earlier on, Stuart had the same problem. He got Cisco-itis. Stuart had Cisco-itis. It was not a dot. He typed something out and it was like, oh, it's all dots. The quad 0, well, it was quad 0 and it was a dot between the quad 0 also. Dot 0, 0, 0, 0, dot, and then more dots, and another 0, more dots. It happens after it happens after a while, okay? It's not a problem. It's treatable. You'll be all right. Okay.
Yeah, I started looking at dots.
I thought so.
That is true.
No more dots to worry about. Okay, 53. We're all getting a bit lighthearted now. So, how you test this floating static route is to verify the path to the R3 LAN. And that's trace route will perform that for you very well. Yeah, I want to get to 192.168.2.1, ping over here, trace route. What's the way through it? It goes number 1, 172.16.2.2, boing, here, 4 milliseconds, 8 milliseconds. And then it goes to the next boing, 192.168.1.1, down here. It's showing you the next hops, boing, boing, that's the hop. Sorry, hop sound there. And over here, Simulate a router failure. So R2 is destroyed, okay? And it's just doing a shutdown actually. R2 go and they config int S0 shut down the interface, yeah? They're saying what happens, and it's going in, it's admin down now, yeah? And then it's going to int S001, which is, where's that one? Oh my God. On R2, this one here, yeah? Shut that as well, shut that and shut that down. This is blow the route up. What's that? Yeah, and that's gonna have to go down this route, you see? Yeah, it has to go down this route. So that's changed, messed that up. And now it's, what says that? Here we go. R2 is deactivated. Is it carrying on from here? Down, yeah, all gone. Show IP. Now, what is the way through now? Please show me the IP route, please. Static, and it's saying it's via 10.10.10.2. Believe it or not, look at that. Yeah, because it now knows the way is this way, only this way. Trace route 192.168.2.1. Now doing trace route. Now, how am I going to get here? This doesn't work anymore. So actually, but it has got a route. Voila. Here we go into 2.1. Yeah. There we go. 192.168.2.1. That's actually the way out, isn't it? R1 tracing to, what's going on here actually?
How about the
Yes, here. To there. Yeah.
Floating route cannot be used.
Cannot be used.
I mean, if R1 is down, is the floating
R2 is down.
there?
R2 is down, not R1. R2. We deactivated R2, this route, yeah?
Oh, okay.
We turned it
If
off.
R2 is down, is the floating route will be still there?
Of course, the floating route was configured on R1, you see. We didn't configure it on R2. That's why we configure it in R1 in a way. Yeah? Does that make sense, folks? So you can see how it's working, illustrated by that example. 56, there we go. So next thing up is configuring the IP version 6 version of this static route, similar commands. What we do is we're going to do IPv6 route, quad 0, a CAD 4:2, which takes us to there. That's our route 1, preferred route. And then other route is a CAD 6, which is that route there. Admin distance of 5 makes it our backup with admin distance, yeah? So that fails, that's the route. How you see what's going on? Did you do route static? So you show run, you can look at that, or you can do show IPv6 route static. That's for your engineering journal for doing tests. Certainly for your troubleshooting activity, that's what you'll do. 57, oh, what's this now? Oh, look, you're configuring some flat static routes in one of your packet tracers there. IPv4 and IP version 6 practice there for you. What's the last couple of slides? That's the last couple of slides for us today. Okay, this bit here, well, what's this bit about? It's just showing some examples of static routes, static host routes to get to servers. 2 examples of server configuration connections there. Automatically installed. Well, okay, it just says host route is an IPv4 address with a 32-bit mask, or IPv6 with a 128-bit. So when the IP address is configured, this is automatically installed, this route. Configured as a static host route, allows more efficiencies, and it's marked with an L. Okay, this is what this is about. In iOS 15, Cisco iOS 15, when those machines come, when you first configure the IP address, it automatically will create the host route for you in that format, yeah? And it will look like this. It will come pre-installed. So it will just automatically configure some stuff up for you. Here's an ISP situation there. Show IP version route. We're in branch, which is that device there, okay? What's the route? It's been given by automatic installation. It's saying that 100.0/30 is directly connected, and it is via serial. And L, which is the local route, okay, is 100.1, which is via 000. It's the other side of this. 100.1 is the other side of it. It's actually the interface point. Let's find it over here. That's the IP version 6 version of it. It's just, yeah, it's the interface point there. So it comes auto-install when you get an IP config in that scenario. Seems to relate to ISPs and servers in that situation. Okay, everyone. So on here, your troubleshooting tasks, the time you've got left, have a flick through these slides. just tells you an example of what's going on here. Okay, read through these slides. I'm going to get you a printout of very useful commands there to help with troubleshooting. If you want to have a go at troubleshooting and it's 5 to 9, go for it. Yeah, you can crack it. Hermione, are you vertical now or horizontal?
Yes.
Yeah, okay. I was wondering there. I'm going to print you the solution, okay, for troubleshooting. If you promise me not to look at it until you've done it, is something you can promise me? Paul, can you promise me that? Yeah? All right then. Come on then, let me get this printing going. And I'll print out a few. What do you want to print it out? Want one of these printed out? This packet tracer? Which ones do you want? Do you want this one? How many of them are there? There's IP version 6.
Yes, please.
And there's this one as well, packet tracer. Let me see how much I've got in my printer, yeah? I'll see what I can do. Now, another thing I'll show you before I get this printing going, and pictures of Frasier on my WhatsApp. What I need to also do is, from within this, I have to show you in YouTube, you also will have companion, they all use CCNA2, companion presentations to support my stuff. YouTube, CCNA2 Chapter 2. What's this? Yeah, they're quite good quality. Static routing done by CJ. It's all right, actually. He's all right, CJ.
On the slide. All right. We need to figure out, well, two networks on the left.
Yeah.
900. The next slide, network you're trying to get to. This is, take us this table down here.
Yeah, there you go. Full chapter. And you know, you've got your labs as well, so I want to do 2.2.2.4.
CJ.
Yeah, CJ's the guy.
Skipping most of the stuff. Oh, I did this. Don't worry about this.
Oh, is he? What, CJ? Is he a bit of a slacker?
Yeah.
Okay, and then you've got this one here, which is
I don't
the
need to explain.
STECACAD doing the... Is STECACAD all right, actually? Is he all right?
Video changed my life. I had this constant need to film.
Oh, come on.
Video on configuring IPv4 or what?
It's my
So,
Indian friend.
why does-
My Indian friend.
It's quite good actually.
He is quite good.
So I'm watching.
You like this one?
And
There's
the
another guy
Oh,
as well.
we rate this guy.
Click this one. This one is quite good as well.
Oh yeah, you Mr. McKee. Oh, is he now?
Yeah.
Is he new kid on the
But I
block?
think he's starting from.
Hi everybody, this
CCNA2.
is Ricky with Net 120 to
Sounds like you. Are you the one who posted that?
that's
No, yeah.
Change your
Am I on?
60 of him as well.
He sounds like Hermione.
Let's go. All right. So let's go ahead and do that.
Sure, man. Okay. Well, you've also got options to choose from, folks, haven't you, really? Anyway, let me get your printouts going. There we go. Let's get your printouts happening, folks.